Welcome, everyone. I'm James Shore, and this is the Art of Agile Development Book Club. Today, we're talking about no bugs, how we can build quality into our software. Our special guests today are Arlo Belshee and Llewellyn Falco. Arlo Belshee is a 20-year legacy code and DevOps veteran with a passion for zero bugs. He's a firm believer in mending code. Arlo's current work is in his company, Dig Deep Roots, where he teaches technical practices that unwind legacy code safely, a code base at a time. Arlo, welcome.
Thank you. I'm looking forward to this discussion.
And I understand you have a certification related to that mending code idea. Is that right?
Yeah. In fact, as we get into some of the topics here, we'll be talking about preventing programmer defects and the like. And the certification helps people learn techniques for safely refactoring code, like truly safely, to bug for bug compatibility level. So we help people learn those techniques as a team.
Wonderful. I'm also very pleased to have Llewellyn Falco joining us today. Llewellyn is an Agile technical coach who is known for strong style pairing, the open source ApprovalTests testing tool, and co-authoring the Mob Programming Guidebook. Llewellyn spends most of his time programming in C# and Java and specializes in improving legacy code. Llewellyn, welcome.
Thank you. It's great to be here.
Yeah, I'm really happy to have both of you here.
And so many great people. It's wonderful.
Yeah. All right, I'm going to get things started by reading an excerpt from The Art of Agile Development. As a reminder, the second edition is out now in both ebook and print editions. You can get it from Amazon by visiting jamesshore.com/buy/AOAD2. And you can find excerpts and bonus material by visiting jamesshore.com/S/AOAD2. No bugs. We release with confidence. If you're on a team with a bug count in the hundreds or thousands, the idea of no bugs probably sounds ridiculous. I'll admit it, no bugs is an ideal to strive for, not something your team will completely achieve. There will always be some bugs or defects. I use bug and defect interchangeably. But you can get closer to the no bugs ideal than you might think. Consider Nancy Van Schoenderwert's experience with extreme programming. She led a team of novices working on a real-time embedded system for farm combines, a concurrent system written in C with some assembly. If that's not a recipe for bugs, I don't know what is. According to her analysis of data by Capers-Jones, the average team developing the software would produce 1,035 defects and deliver 207 to the customer. Here's what actually happened. The GMS team delivered this product after 3 years of development, having encountered a total of 51 defects during that time. The open bug list never had more than 2 items at a time. Productivity was measured at almost 3 times the level for comparable embedded software teams. The first field test units were delivered after approximately 6 months into development. After that point, the software team supported the other engineering disciplines while continuing to do software enhancement. Embedded Agile project by the numbers with newbies. Over 3 years, the team generated 51 defects and delivered 21 to its customer. That's a 95% reduction in generated defects and a 90% reduction in delivered defects. We don't have to rely on self-reported data. QSM Associates is a well-regarded company that performs independent audits of software development teams. In an early analysis of a company practicing a variant of XP, they reported an average reduction from 2,270 defects to 381 defects, an 83% decrease. Furthermore, the XP teams delivered 24% faster with 39% fewer staff. More recent case studies confirmed these findings. QSM found 11% defect reduction and 58% schedule reduction on a Scrum team, 75% defect reduction and 53% schedule reduction on an XP team, and 75% defect reduction and 30% schedule reduction in a multi-team analysis of thousands of developers. How do you achieve these results? It's a matter of building quality in rather than testing defects out. Eliminate errors at their source rather than finding and fixing them after the fact. All right, let's go ahead and get started with our first discussion prompt. So the book discusses 4 ways to prevent errors and building quality in, and that's preventing programmer errors, preventing design errors, preventing requirements errors, and preventing blind spots. And I'd like to start out with programmer errors. And let me direct this one at Llewellyn to start with. Well, what's your go-to techniques for preventing coding mistakes?
Tests, unit tests.
Mm-hmm.
When you say programmer errors, like the way I think of this is these are things I expect to work and I just want to make sure that they do.
Mm-hmm.
And that is, I think, where a lot of programmers who don't do unit testing spend so much of their time, right? And unit testing allows me not to spend much time at all there. There's still those other bugs you talked about.
Right.
Those are tricky spaces and big spaces. So there's still like a lot of stuff to consider after that. But just knowing that, like, I think this does this, it actually does this, is really valuable. And if you think of like even just compiled versus non-compiled languages, just knowing your code compiles gives you a certain amount of, like if you were to type your code in Notepad and then we're told like, hey, this compiles, or if you had like, say, JavaScript and it was like, well, I don't know if it compiles because there's no JavaScript compiler. Like that gives you a certain level of confidence. Not much, but like more than I just type something in Notepad, right? Running your code, just running it and not having it explode gives you like another boost of confidence. Running your code and seeing that it returned the right answer, like that's like a whole nother level of confidence. And knowing that it repeatedly runs and gives the right answer, like that's sort of like, now we've solved programmer bugs. Now we can start talking about much more difficult bugs.
Mm-hmm. Yeah. Arlo, what's your take on this?
I agree on the value of programmer tests, unit tests early on and with new code. And I find them insufficient as products start to grow. My real concern, I spend all of my time on ancient code, things that have been delivered to the customer for 35 years, and people's careers have gone through and ended, and they've retired before the code has. And on those systems, the definition of correct really has shifted slowly over time and has never really been known. And so in that case, it's all about refactoring. And what I find is that there's like tests give me one level, which is when I know I'm changing the functionality of the code, am I changing it in the way that I intended? And that's a really important level. But what they don't tell me is what unanticipated other side effects did I have when I changed the code? And
yeah,
so
there's really two things. Like one is preventing programmer bugs when you're making new stuff.
Yeah.
The other is preventing programmer bugs when you're changing existing stuff. And you're absolutely right about this.
Exactly. And so in that sense, then the best that I can do is split my work so that I'm refactoring or adding new. And when I'm refactoring, I need to hold myself to a higher standard. And so that's where I use provable refactorings and automated tools and structure and static analysis, because I need bug for bug compatibility. I need to know for a fact that I don't accidentally fix a bug that I don't know exists because the last person who had the conversation with the customer about that retired 10 years ago, right? And so that level is doable, but that's where the compilers and type systems and all of those come into play. It's your only option. And so, yeah, I do that for all the refactorings, and then you get it down to the point where any functional change you're going to make is a one-liner, and you unit test the hell out of that one line.
Mm-hmm. Mm-hmm. Now, Llewellyn, you of course are known for the approval testing framework, which is, I think, also meant to help provide some safety when you're refactoring existing code. Do you want to say a little bit more about that?
So approval test allows you to verify more complicated things than numbers, right? So like unit tests usually have asserts, and you can say like 1 equals 1, or, like Fred equals Fred. But what happens if you get like back a JSON string, or if you get back like an image? Like, how do you verify that your image hasn't changed? Approval test allows you to do that. So it sits under unit testing frameworks, and it's like a verify extension. And one thing, because it can handle very complicated things, we'll often do like combinatorial tests where you'll say, well, I got this function and it takes these two inputs, and here's 10 values for the first input and 10 values for the second input. Give me the matrix of all 100 of these combinations, and then just snapshot that so I know it doesn't change. And it's a very nice way of getting high, not just test coverage in terms of lines of code, which is important but far from significant, but more like heckle proof, meaning like if a single piece of functionality actually changes, you are aware of it.
Yeah.
And often it's just a lot of stuff, but there are actually situations where it can be complete. Like when the numbers are below 100,000 for your combinations, you can just test everything because the computer's fast.
Mm-hmm.
I'm actually using approval tests right now on a project to get to address one of those later ones of requirements problems, where we've got a really good expert. It's doing estimation of like building construction projects for sky rises, and he wants to make a tool that estimates that. And so we're able to take the entire rules engine of all the computations, including all of the transformations between units and everything like that, and have it output and verify with the approval test the set of computations that are going to happen. And then for any computed estimate, we have the entire backtrace of what was all the logic that led into every calculation, and it can output that. And so he can quickly look at things, and as we implement a feature, he can see the diff, because approval tests make that nice and easy. And he can see, okay, we implemented this and we added that computation, we modified that computation, and we got that one. It's right, we're good.
Again, love to hear from everybody in the audience to participate. Just raise your hand in Zoom. There's some good conversation in the Discord around the topics we had this week. And if you're not familiar with the Discord, you can join it by going to jamesshore.com/s/AOAD2 Discord. Jay Bouzizi talked about using safe technology as one of his techniques for reducing programmer bugs. So for example, garbage collection being safer than memory management. He also mentioned code formatting as a way of reducing the likelihood of errors. Linting and static analysis. Of course, functional programming is famous. Functional programmers are famous for saying, well, if you know the type system, it's provably correct. I don't know if I buy that, but yeah, I'm seeing some head shaking, but it's definitely another level. It reduces the amount of other types of testing that you need to do, really reduces your attack surface or your failure surface. I saw a hand go up for a moment, but then it went back down. So, oh yeah, I'm going to try to pronounce your name. I hope I get this right. Is it Junilo? Anyway, welcome to the show.
I did want to mention, besides the techniques that Llewellyn and Arlo already mentioned, I think for us, because on my team, I really emphasize the collaborative nature of development, that we were either going to pair or mob. And I think that does a lot to get everybody on the same page, because when everybody on the team doesn't understand where the design is going and what the purpose is, and you don't share that kind of ubiquitous language about your code and the purpose of the code, then I think that's the source of a lot of misunderstanding and where a lot of these programmer errors come. So I think there's a lot to be said about pair programming and mob programming as well.
Yeah, absolutely. And not just programmer errors, but I think also design errors, which is, and so thank you very much for your comments. That actually takes us to the next topic I wanted to discuss. So
it also brings up like just the idea of readable code as how important that is. Like you mentioned formatters before, but I think Arlo shared a study once where a lot of bugs are related to the white space around code. I mean, in the comments, right? Like white space and comments don't compile, but it's indicating that the stuff that does compile is confusing to the programmer, right? And that space between what the code actually does and what the programmer thinks the code actually does, like that space in between, that's where bugs live, right? And if you can shorten that distance, it's harder for bugs to survive.
Mm-hmm. So yeah, let's talk about design defects. So this is where the design it's sort of what you're getting at here, Llewellyn. The design of the code just encourages misunderstanding, as it leads to defect-prone code.
Yeah.
Arlo, what's your thoughts about that?
Yeah, so my perspective on this is architecture I don't find to really matter that much, but design is critical.
And what's the distinction you're making there?
Yeah, okay. And yeah, what I mean is that the vast majority of bugs that happen are due to not understanding the code that's in front of you. The second most common is spooky action at a distance. It's not understanding how this code interacts with some other code out there. right? But the most common is just the illegible code, and depending on the studies I've seen, that's well over 80% of all the bugs. And then you start looking at what results in those things, and the top ones are, excessive uses of exceptions, but that's like fourth or fifth, right? Memory management, that's like third or fourth. Concurrency, that's like second. Number one, long methods. Like, I can't read the freaking method. Or I think actually crappy names was even above that. But it's the very simple stuff of just the human mind has a limited capacity for the number of things we can retain at once. And the way our brain works is when we are presented with more than that amount of information, we drop some of it. And the brain sort of vaguely remembers that it remembered something, which gives us the confidence to continue making decisions, but it's in absence of that information, right? And so whenever a method or a piece of code is longer than that, we just fundamentally cannot take into account all the information that's there. So we're guaranteed to, it's that distance that Llewellyn was talking about. Our conception is different from what the code actually does, and bugs will happen, right? And so long methods and bad names create additional things that we have to think of. Long methods increase the number of things we have to hold at once, and crappy names create that remapping where it says foo, but foo means, right? That's one more fact that we have to remember. So both of these just overwhelm developers. And that's where I say design is key. It's getting that stuff right. And then everything beyond that, the larger scale things, they matter some. They lead into things like spooky action and distance. They lead into the amount of code that you have to change, duplication, all those sorts of issues. But they're far less in terms of the number of defects caused. And so do it when you got the other part right.
If your methods are smaller, you will just have less duplication, because you'll be like, oh, I can just call that. Like, if the method already exists, you don't rewrite it, you just call it, right? If the section you want is in the middle of your code, then you copy and paste.
So I've been hearing something lately, and it sort of surprised me. So I read Hacker News, which sort of a hive of scum and villainy sometimes. But one of the things that I've heard in some of the threads there recently, which really surprised me, is a real backlash against short methods. People saying, well, I need to know what everything does, and if it's not right here in front of me, I don't really know how the software works. So let me give Llewellyn a chance to respond to that one first. What's your take on that?
So first of all, I just don't understand that. But I've noticed that there are some people who seem to be able to function, and I don't want to say function well, right? But function in long methods, which I cannot. Like, I am really bad at handling long methods. So I got really good at changing long methods into short methods.
And let me clarify, when we're talking about long methods, we're not just talking about sheer numbers of lines, but we're talking about lots of nesting, variables that are up here that affect things that happen down here, and so forth, right?
Absolutely. But over 20 lines in a method, I cannot hold it all in my head. And I am not good at dealing with not holding it in my head, right? Like, so like there are people who seem to be like, well, I kind of understand this part. I kind of understand this part. I can do something. I'm like, I keep getting like, no, I don't quite understand this part fully. And like my brain doesn't let me move on. So that deficiency has been actually really helpful for me in being like, let me get my code into chunks where I can actually understand each section. And so even, most methods, I look at it and I'm like, well, this paragraph, and as soon as you can say that should be a method. Mm-hmm. Put that in, give that paragraph a title, and now you don't have to look under the covers. Yeah. And that's also why like I was in a company, they had SonarQube, and SonarQube wouldn't let them have long methods, right? And so they would literally just chop the method up sort of indiscriminately, and they were horrible methods. They were so hard to understand, right? Like the paragraph of like that, and then even better if it can be a functional paragraph where it's like, I have very clear boundaries. This is what's going in, this is what's coming out, right? As opposed to this global state of
no side effects. It goes into, goes out to, and that's it.
Exactly. Yeah. That makes it so much easier for me to understand. And the other people, they say they understand it, but their code has bugs. So I'm not sure I believe them.
Yeah. What about you, Arlo? What do you think?
So the things that I've seen, I have seen very commonly this thing of desire for long methods, and it's I looked into it a lot actually around 2010 or so with a bunch of teams that I was working with, and what I found was universally the people who needed long methods and preferred them were the ones with some experience who had been burned over and over by misleading, dishonest names.
Yeah,
and so as soon as they found a code base in which the names were actually trustworthy, saying what wasn't known, admitting the faults and weaknesses of the code, actually being completely blunt and honest, they immediately swapped back to wanting very clear, defined, well-defined methods. And in fact, they would look at the ugly, terrible names and say, this name tells us this method needs to be broken up. Let's break it up.
Yeah.
Right.
I think that's a great point. And I mean, I first ran into this back in 2000, and I really had trouble with it. But the argument was, well, I need to read every line of code to really know what's going on. So so I want all the lines of code in front of me. I'd like to invite Jay Bazuzzi on up. Jay, welcome to the conversation.
Hey, hi folks. I want to add one more reason I think that people sometimes find themselves comfortable or drawn to long methods, which is that as a programmer, if I succeed at making the change in gnarly, complicated code, I feel awesome. Yeah. And it creates this feedback loop of like, I'm so smart, I'm so capable, I've overcome this enormous challenge. And when code is simple and easy, I don't get that feeling back. I don't think this is the goal, but I think that it draws us in that direction.
I think you're so right there. I mean, there is this definite attraction to creating really complicated stuff. You see a fair amount of resume-driven development out in the world, and I think that has some of this. It's a similar motivation, not exactly the same. Thanks for your comment, Jay. I'd like to invite Drew up as well. Drew, welcome.
Hey, good morning. I was going to echo a couple of things that both Llewellyn and Arlo said. I think, first of all, Arlo mentioned a couple comments about, experience with legacy code and what happens when you're dealing with a legacy code base, particularly with, developers who have been there for 20 years and wrote it from the very beginning. And I think there's a number of kind of team cultural issues that go into that. And I've seen where, you have long-standing teams who've owned a code base for a long time, and particularly fractured teams where, one person has owned this portion of the code base and they do it, another person owns this. They tend to write really long methods because it's just them. It's all in their head. They've worked with a business stakeholder. They understand what this thing's supposed to do. And there was no reason for them to split up. They just wrote this big, long method because it did everything they wanted it to do. And, they ended up with it. And in situations where a team owns a code base and you have more people in there, more people working on it, I think the natural tendency is to break things up more into small chunks for coordination, for, when you get collaborative design in there, people, thinking about it that way. But the other piece that I found is just from a testability standpoint, to what Llewellyn was saying, if you see a code that has multiple paragraphs and you can say, hey, this section of code does this section does this section does this, it's really hard to test all of that when it's all lumped together into a single method or something. And so just from the perspective of writing testable code, I found it really difficult to have extremely lengthy methods.
Yeah. Any thoughts on that, Llewellyn or Arlo?
Well, so if you have a really long method, like imagine your whole code base was just one method, right? Which, maybe is like a main method in like Word or something. You can't test just a section of that easily. You have all your unit tests all of a sudden become like full stack tests because you got one entry point and one exit point. Like multiple entry points is how you get little pieces of the code defined and tested. And so if you don't have those multiple entry points, you can't do anything. I totally agree with what you're saying, Drew.
Thanks.
And
go ahead, Arlo.
Yeah. And I find that's actually often a factor that causes long methods, ironically. When I get into, when code surpasses a certain length of method, and I don't know exactly what that is, but it's somewhere between 100 and a couple hundred lines, then there is no longer anyone on the team who feels safe enough to modify it.
Mhm.
And therefore there's no one who feels safe enough to test it. So it's guaranteed to become untested over time, no matter how tested it was. And teams naturally swap to a least invasive change approach, where you try and make the change that modifies the fewest lines of code every time you're adding functionality. And those changes are guaranteed to add net new lines of code. There's no way that you can do it otherwise. Yeah.
Michael
Yes,
Feather did the Delta Flora project where he did stack analysis over time in the source control. And he saw that exact thing, which is methods would go up and down, up and down, up and down. And there was a different number for each company, but eventually they'd hit a point at which they only ever went up.
Yep.
Right. And unless you learn how to extract paragraphs that you don't understand, you have no way to refactor that code. Right. Like the thing that extracting paragraphs with the read-write refactoring allows you to do is say, I can pull out this clump of code that obviously goes together, even though I don't understand what it does. And that's the key to breaking apart methods that are huge that you do not understand.
Absolutely. And that's why in read by refactoring, I hold Applesauce as the most important single technique, even though it is the most contentious.
People might not know that technique. You want to explain it?
Yeah. So that technique is very simple. When you see a bunch of code that you don't understand, grab a chunk that hangs together. Paragraph is a great way to do it. Extract it, name it Applesauce. It's a glaringly, obviously wrong name. So at least it won't be dishonest. Like, it's honestly saying, I have no freaking idea what this code does, but I know it hangs together, right? And that in and of itself is enough of an insight, and an important enough one. You often need to do it several times before you can start to figure out what any of those chunks really are. And then you start including those in the names and all of the later steps. But that is an absolutely key step, that extract method without knowing what it does.
Well, I think we could spend all day or all session on this one topic, and I see that there's some hands raised, but I'm actually going to move along. So I apologize to those of you who didn't get to speak up. So our next topic is requirements defects, and I'd love to hear your thoughts about preventing requirements defects. This is and by requirements defects, I mean shipping the wrong thing or misunderstanding something important about what needed to be shipped. And let's have Llewellyn take this one first.
So I used to date an exploratory tester, and she took a look, and she's like, oh, I'll take a look at approval tests. And I was like, oh, go for it. Like, this code is test driven. It's like the code I'm the most proud of.
Sounds like famous last words to me.
Oh my God, destroyed it. But in things that I don't even know how to unit test. Like, one of the things was, she's like, oh, all your code samples are images. And I'm like, and she's like, you can't copy and paste them. Like, it's really hard for a beginner. And I was like, oh yeah, that's a pretty good point. Like, you can't copy it. So there was like just a whole bunch of usability stuff. It's like, it's one thing to have the stuff you expect to work. And when I think of no bugs, I usually think like that's sort of the level that we're looking at, is like months between bugs of stuff I expected to work that didn't. But then there's this stuff where it's like, I didn't expect this, but now that I'm aware of it, I have expectations around it. Mm-hmm. And that space is probably infinite.
Yeah.
And so exploratory testing is an amazing way of doing this. User tests, watching someone use your system. There's a certain person who may be on this call, maybe leading this call, who once did a video on approval tests. And I got to see the YouTube of that, and I'm screaming at the screen. And that was the first time I ever wrote documentation for approval tests. I was like, I never want that to happen again. But it's obviously not the first time it happened. It's just the first time I knew about it, right? Mm-hmm. And so like getting to see your users where you can't interact with them and how they use your product, that is so valuable.
I think I know the video you're talking about.
You just might.
Arlo, what's your thoughts about this? But actually, before I want to just sort of highlight something you said, Llewellyn, which you talked about exploratory testing as a way of identifying sort of flaws in the usability of your code. And that's something
Yeah.
I'd never thought about. I think of exploratory testing as finding blind spots, and I suppose that's a sort of blind spot.
Yeah, it's a blind spot. Yeah.
But I usually think of it the more technical blind spot. So that's a really interesting point. Arlo, what are your thoughts on this?
So I agree with everything Llewellyn is saying, and to me, a lot of it comes down to the predictability of bugs. There's quality issues where you can know a priori what correct is, and then there's quality issues where you cannot. And so I just step into celebrating that requirements is an area in which most often you cannot. You will get one answer from interviewing a user or even giving them some examples. And then when you give them a running program, their answer of what they want to do will change. Because they have observed this program, they will now see new possibilities and they will change their minds.
Yeah.
And so there is absolutely no way you can know what correct is. And so that's where I say you just have to embrace that, love that, make that so your code is trivial to change in known ways and you don't screw something up when you change it. See also the two previous categories. And then once you've mastered that, now you can be responsive to your actual customer. And now you can do test in production. And now you can do lean startup. And now you can do real exploratory testing and real user testing and all those things. But you first need to have absolute ironclad ability to see them have a problem and just make a design churn, get it out in front of them in 3 minutes, knowing for a fact you didn't screw anything else up. Because if you make another bug, that'll corrupt your data. And that's even worse than having a bug that annoys users. I'm in the middle of a user test. I'm choosing which way to go. If I introduce a bug, that'll change people's behavior, and they will now ask for something that is different than what they want. And when I finally release, I'll have a real big requirements bug, right? So I need to have very clean first two steps and then respond to change.
So much in that. First of all, like Alan would always say, Shalloway, he's like, users don't know what they want until they see what they don't. That is part, like we are designing new stuff, right? And when you design new stuff, that is an exploratory process, right? So you are discovering what it is you want to build. The other thing that you said there is optimizing for change, right? And for me, that is good design, readable code, and unit tests. Those three things together allow me to, and CI, the ability to actually get it back to the user. Like those things work together to make it so that it's cheap for me to change when I realize what the right direction is. And that's very important. The other thing that you mentioned here is if you break things when you change stuff, you were saying like it gives you bad data, but it also erodes confidence to allow you to change in the future.
Yep.
Like I know places that are like, well, we're not upgrading for a couple of years because we know this works, and we don't know if we upgrade, maybe it won't. If you want to break that cycle, you need to make sure you don't regress when you release.
There's a comment in the chat sort of agreeing with what you said from Steve Kuo saying, being able to observe an end user using your product is worth its weight in platinum. So much valuable feedback, including finding defects.
Yeah.
I'm going to move us on to our final topic since we're almost out of time today, and that's blind spots. So the stuff that your team is not even aware could be a problem, just has no clue that this could ever be an issue. And of course, defects and things like SQL injection is kind of a classic one, or not defects, but security issues is a classic one. But it's not the only category of blind spots. So what are your thoughts about discovering blind spots, preventing blind spots? Arlo, why don't you kick this one off?
So that's where I do safeguarding. So safeguarding is all about random sampling the bugs that do happen. If you are a zero bugs team, your random sample can be 100%. That's awesome. If you're not yet a zero defects team, your random sample may be a smaller percentage. But random sampling those and then looking at the contributing factors. What caused a well-meaning, highly skilled developer working with other well-meaning, highly skilled developers, all trying to protect each other to do this screwed up behavior, right? What were the system influencers that caused that, whether it's code or process or lack of skills, or it could be any number of different things. And so once you've identified those, then and it's similar to a root cause, except you don't assume there's one, you assume there's many, and you find many. Once you've found those many, you make a small incremental investment on each of several of them, whichever were most impactful. And you do that over and over. The result is that you make more investments on the systematic causes that are causing more bugs or worse bugs.
Change the system.
And that starts at changing the system, resulting in a safer environment. And when the environment gets safer, then you don't require everybody to be so careful, and those sorts of blind spot bugs go away.
Mm-hmm. What do you think about Llewellyn?
I mean, so I'm a huge fan of safeguarding. I think of it as smoothing the road. If I tripped, let me smooth the bump, and next time it's less likely I'll trip. And over time, if I keep tripping on it, it gets smoother and smoother, and eventually it's not a problem. But in terms of blind spots, diversity of thought is a thing. And obviously just actual diversity will like hit diversity of thought, but that's like, it's not enough just to have like a diverse team. Like you actually have to listen to the diverse team, right? For me, mobbing is an excellent solution for that. And once you start mobbing, you can start adding people who aren't programmers, right? This worked even better in the before times when we'd meet in person, because just a group of people is interesting to other people. Right. So I remember one time we had an artist join us, right? Just literally because it's like, oh, you guys seem to be laughing and having fun. Like, let me see what this is about. And we were working on an icon that he had actually developed, and we put it in, and it was the wrong size. And the program's like, oh, no problem. They hit the resize, and he was just appalled. He's like, what did you do to my graphic? And we're like, no, it's the right size now. And like, so he whips out his computer and had Photoshop on it, which we did not have, and even if we didn't know how to use, fixes the graphic and sends it to us. And then we have a right-sized, beautiful graphic. And it's like that whole conversation never would have couldn't possibly happen in the group of programmers that we had. Right. So like when you bring in your testers, they will think about things that you are not thinking about. When you bring in your users, they will think about things that you are not thinking about. So the more people that can like come into the mob who are involved in the project, the more pieces of thought they will naturally think of that you're not thinking of. And so it doesn't remove the blind spots that you don't know about, right? Like there's still stuff that entire group doesn't know. But at least the stuff that the group does know is being shared. And the one thing that we do in the mob that's the most useful for this is if multiple ideas are in play, we try all of them, right? So we don't argue like which one should we do. We do them all and then we decide. And that allows us to have actual understanding of what the idea is, regardless of how charismatic or convincing or articulate the person is who had the idea.
Mm-hmm. I love this point that you're making about true diversity of experience, and artists bringing something to the team that the programmers on the team didn't have. And it just makes me think that this is where exploratory testing and penetration testing for security helps, because really what it is it's a deliberate way of bringing new perspectives into the team.
Yeah.
We are getting short on time, but I want to give Arlo a chance to share some final thoughts. What are you thinking, Arlo?
Yeah. So a couple of things. First, just building on that, I really see the history of extreme programming as being the invitation of one more group at a time. We started with testers, and we were going to make testers and eliminate the difference between testers and developers. And to some degree we did, and we pulled some stuff in. And to some degree we invited testers into the camp, right? And then we started bringing in product managers. And then we started bringing in the first line managers. And then eventually we realized there was a whole ops team that we'd never talked to, and poof, DevOps, right? It's the natural evolution of the whole thing of XP. And that shows up in the book that we're talking about here, where this book is rooted very deeply in the developer experience. and also in the tester experience, and also somewhat in the, it goes a little bit lighter in the manager and product manager experience, but it's still there. I mean, you're talking about the way that companies should be organized. You're talking about governance. These are in XP. They're not exactly in the developer domain, right? So I think this is just a really good example, and it shows as you start to look at all the meanings, bringing it back to the zero bugs, all the meanings of the defect elimination, and it's really how can we go forward with fewer unanticipated side directions, right? And how do we not explore the same wrong direction multiple times? This is a continued evolution as we find more people and figure out more systematic ways to incorporate those thoughts, whether it's mobbing or beyond budgeting or unit testing or refactoring, right? And so that's where I see the continual evolution of what we're doing around software development.
Fantastic. I can't think of a better place to stop for today. Thank you all for participating. Thank you, everybody who had something to say. Llewellyn and Arlo, I particularly appreciate you for joining us
Great to
today.
be here.
Llewellyn Falco is an Agile technical coach, and Arlo Belshee is founder of Dig Deep Roots. Next week, we are continuing the quality discussion by looking specifically at blind spot discovery. Janet Gregory and Abby Bangster will be joining us to talk about how you can discover what your team doesn't know that they need to know. That is July 15th at 8 a.m. Pacific. The free reading is already up at jamesshore.com/s/AOAD2 book club. You can join the Discord conversation by visiting jamesshore.com/s/AOAD2 Discord. That is it for today. Thank you again, everybody, for participating and for joining us today. And I will see you next time.